Hello, Apple Valley High School students. Today I'm going to show you how to do some curved mirror drawings. And in the packet that you have, there's this page that has different examples of curved mirrors and then the images that are formed. And the ones that I'm going to show you are case 2 and case 4 and case 6 and then case 8. So I suppose you could say we're going to do all the even examples of curved mirrors. So you have a drawing notes sheet, and it looks like this. And what I want to do first is show you what each one is, what case it is. So this first drawing is actually, if you look in your that sheet I just showed you, this is case 4. So I'll just kind of make a little note of that. So if you get confused on what I'm doing, you can kind of refer back to that. The one below it, the next one down, that would be case 2. And then the one below that would be case 6. And then the bottom one is actually case 8. So the first 3 are concave mirrors, and then the bottom one is a convex mirror. So when you do these drawings, the thing that you have to look at is 2 light rays, and one of the light rays always goes parallel to the principal axis. The principal axis is this line here, and the second light ray that you're going to draw will go through the center of curvature, which is this point here, C. So what I'm going to do is I'm going to measure the height of the object, and the object's an arrow, and I'm going to duplicate that height on the lens to make sure that the light ray I draw is going to be parallel. And because I'm using a see-through ruler, I can kind of get a little better picture that it's going to be parallel to the axis. So that's the first light ray. Whenever you draw light rays, you have to put an arrow on it. And then that light ray, because it's going parallel to the principal axis, it's going to reflect through the focal point. So you can see I line up my ruler so that the light ray goes through the focal point. I'm going to actually extend it quite a bit because I'm not sure where the image is going to be located, but it's going to be somewhere along that light ray. The second light ray we draw just goes through the center of curvature, and it leaves the top of the object. So I put my ruler at those 2 points, and that light ray actually leaves the object, so I'm going to draw it from there first. It strikes the mirror and then bounces back through the center of curvature. So I'm going to draw it all the way back, and then it goes past that other light ray, and where they intersect is where the top of the image is going to be. So this point right here, the object, is what I duplicated right there. So notice I have the head of the arrow object here, so the head of the image object has to be here. So when I draw the image in, it's going to be upside down because the light rays cross after they reflect, and that's why you get an inverted image. And it's going to be a real image because it's made by real light rays. And notice that it's larger than the object. So you want to make sure that you label that. And then you want to tell us 3 things. Say it's over here. State if the image is real, virtual, inverted, upright, larger or smaller than the object. So you can tell that this image is real because it's made by real light rays. So the image is real. And it's inverted and larger when compared to the object. You always have to compare the image to the object. All right, so that's case number 4. So that's when the object's between the center of curvature C and the focal point F. The image will be located beyond the center of curvature. All right, that's case 4. Now we're going to move to case 2. And now you notice that this is actually switched positions. Now the object's way beyond the center of curvature. So guess what? The image is going to be found in here. So I'm going to do the same thing. I'm going to measure the height of my object and then duplicate that height on the mirror so that I make sure that the light ray is parallel. And then because I've got my see-through mirror, or see-through ruler, I can really check that to make sure. And that's one of the things that I'm going to look for when I grade these. I'm going to look for this parallel light ray. So if it's not parallel, you won't get full credit. So there's that light ray going straight, and then it reflects through F. So I'm going to line up my ruler with the light ray where it hits the mirror and then the focal point. All right. Second light ray goes right through the center of curvature from the object, strikes the mirror, and then hits back along that same line. So you actually draw a double light ray. So I have a light ray going in, and you show the arrow going in, and then the light ray going out. And so the image is going to be found right where they intersect after they reflect. And I think, well, I better show you on this one. I didn't draw the 2 arrows on that one, so I got to make sure I put that in there. So that one's correct. So back to case 2. So the image is going to be right here. And again, it's going to be inverted compared to the object. So you have to actually show that. So I have my arrow upside down. I'm going to label that as the image. And then what do we know about that image? The image is inverted, smaller than the object, and it's real. It's made by real light rays. So this is one in class where we were looking at the big curved mirror, and people said that their eyes hurt or their brain hurt, and that's because you see it out in front, but your brain says it's smaller, so it should look like it's further away, and it really isn't. All right, that's case 2. Now we're going to move on to case 6. And in case 6, the object's inside the focal point. And this is when you had the curved mirror close to your face, and it kind of looked like a makeup mirror then, and the image is really big. But we're going to do the drawing the same way. So I'm going to measure the height of the object and duplicate that height on the mirror. And again, I'm doing that just to make sure that my light ray is parallel to the principal axis. And the principal axis is that line that cuts right through the middle of the mirror. So there it is. And that's going to reflect through the focal point, just like that. And this one, the image is going to be virtual. So I'm going to actually dash it back, because what you're going to see is the light rays after they reflect aren't going to intersect on the object side of the mirror. They're going to actually intersect behind the mirror. So I have a light ray, got to show the direction it goes. And then I dash this back because that's going to be a virtual light ray. And then the second ray I draw, I line up the center curvature with the top of the object and draw my image in like that, or the light ray, and then it bounces through C. And so you notice that it's not intersecting out here, so I have to draw the light back to where it looks like it's intersecting. So I'm going to use a dash line to do that. And remember, those are virtual light rays, so they don't have arrows on them. And so you can see that it looks like the light came from here. So our eye would be out here looking, you'd be looking in that way and seeing the image right about here. So I'm going to draw on that image. And notice that the image is bigger than the object, and it's located on the other side of the mirror from the object, so it's made by fake light rays, so we call it a virtual image. So the image is enlarged, and it's larger than the object, and it's virtual. So it really only exists in our head. All right, one more to draw. The last one is for a convex mirror. All these were concave mirrors. So now we're going to do a convex mirror. And there's only one way to draw the image for convex mirrors, and that image is always going to be virtual. So that's why they only have one. The concave mirrors, you have 3 different types of images that you can draw. So again, I'm going to measure the height and duplicate that height on the mirror just to make sure that when I draw it, the light ray, it looks like it's parallel. And this one, this is the focal point here, and then the center curvature is here. Notice how it's on the opposite side. This is actually called a virtual focus and a virtual center of curvature. So, and that's because the light rays diverge when they strike the mirror. They go away from the principal axis. So here's the first light ray, goes parallel, and then it actually reflects up. And on the test, most people are going to forget to draw this line I'm drawing right now. They just forget to draw it. Biggest mistake. So don't make that mistake. And then I dash it back because that's a fake light ray. Put an arrow on here to show the direction the light's going. And the second light ray we draw goes right through the center of curvature. So I'm going to line up my ruler with the top of the object and C, and then it goes straight in, and then it bounces straight out. So it looks like that light ray is coming from back here. And you can dash it all the way back to see if you want. You don't have to, but you can. You for sure have to do the intersection point. Double arrow because it's going in and out. And then where the light rays look like they're coming from is right here. So that's where my image is going to be. So I'm going to put in my image and put an arrow on it because you have to say its orientation. Label that as the image. And then we can say the image is virtual, upright, and smaller compared to the object. And there you have it. Those are the different ways to draw images for curved mirrors. Hope this helps. Have a nice night or afternoon or morning or whatever. Bye.